All right, class. Next thing we're going to learn is just the ways to combine the laws of logarithms. So it says in this lesson, we will study examples which combine the power law with the product and the quotient laws. So there are three main laws of logarithms, as you can see here. You can go back and forth either way. So super important that you remember that. I'll try to make this a bit bigger for you. So you can go either from the 1 log to 2 or from 2 logs to 1. And yeah, just keep that in mind. And so there they are. The product log, 1 log of 2 things being multiplied becomes 2 logs with the arguments added. And then you have your division becomes subtraction. And then you have your power law, which says this exponent on the m can come down and multiply the logarithm in the front. All right, so students were asked to express 4 log base x of 2 minus log base x of 8 in terms of a single logarithm. The work of the 3 students is shown below. And then we can look at it, and it says only one of the students has determined the correct answer. Determine which student is correct and explain the error. So we begin. So you can check it out. You can try to check maybe. Let's look at Shane. So he put the 4. Oh, he turned the 8 into 2 base 2 with an exponent of 3, which is allowed. And then he put the 3 down in front. Now he has log base x of 2 on both sides. And he says you have 4 of those, take away 3 of those, leaves you with 1. That looks pretty good to me. Let's go on and see what we can find with Emma. What did Emma do? Emma put this coefficient that's multiplying the log. She wrote it as an exponent of the 2, which is totally allowed. And then she said 2 to the 4th is 16. Good stuff. And then she wrote log 16 minus log 8 is somehow log 8. No, this is wrong, right? It should be, if you have 2 logs being subtracted, they can become 1 log with the arguments divided. You don't subtract the arguments ever. So this is wrong. Okay, let's look at Clayton. What did Clayton do? Clayton somehow put this 4 up here and got an 8. What did he do? He multiplied the 2 and the 4 rather than raising it to the power of 4. So this is definitely wrong as well. So Shane is correct. All right, so I just explained what the other 2 mistakes were. Let's go on. Use laws of logarithms to write each of the following as a single logarithm. So we've got a half and a third. Okay, that's okay. We have different bases, but no big deal. Let's just start. Let's deal with this 1/2. So if we convert this to an exponent, it will be log base a of 16 to the 1/2. And we can do the same thing. We can subtract and put this 1/3 on the 8. Okay, now you have to know what those fractional exponents do. It's so important. Fractional exponents can be written as radicals. So log base a, this is the square root of 16 minus log base a and the cube root of 8, right? The denominator of the exponent becomes the index of the radical. So now we can just do it. And the square root of 16 is 4. And the cube root of 8 is 2. Now we have 2 logs of the same base being subtracted become 1 log with the arguments divided. The math. There. So important that you get to a single logarithm like it said. Okay, we have to get to 1 log. Very important. Nice pause there. Okay, let's go over here and see what we can do. I'm just going to take these 2 things first. Oh, actually, I think before I subtract those, let's kick the 5 upstairs. So we're going to take this 5, we're going to put it up here. Copy the rest. Now I have 2 logs subtracted. I still am going to write this down. And then I'll go 2 logs subtracted again. Kind of looks like that. So when you do a over e to the 5 divided by a squared, if you remember what that does, it looks like this. You flip in times. So that's going to become a over e to the 5a squared. You following me? Okay, but then this a and this a cancel, and you have 1 over e to the 5a. So that's what this is going to be. Log of 1 over e to the 5 and an a, like that. So there's a few steps that you got to work on. Probably we could do that differently. I see it that we could do it differently. Maybe I'll show you that really fast. I just double checked and saw I could do it. What if you had done it like this? What if you had done minus and you brought that one down front on the a? The log a here, if you brought that 2 down front, then couldn't you take this log a minus 2 log a? Oh, then you have a negative log e to the 5 minus log of a. Oh, then you have to take this negative, throw it up here, so it's still complicated. But it might be easier. Then this becomes, I'm going to divide those, but this is actually 1 over e to the 5. So we're going to end up with a and e to the 5 on the bottom too. Maybe that's not easier. Okay, you can ignore that if that was complicated. But if you can see it, it'll go. Okay. Now, what's this? Write the expression 2 log base 6 of 4 plus log base 6 of 2.225 as a single logarithm. Okay, so what would I do here? I think I would put the 2 up on the 4. So let's do this. Let's make that 4 squared. Copy down the rest. All right, then this becomes log base 6 of 16. Now you have 2 logs, same base, being added. So that becomes 1 log with the stuff, or the arguments, multiplied together. So when you do that on your calculator, you get, let me double check, 36. Ooh, and log base 6 of 36 is just a plain old 2. Nice. All right. So this kind of question says, if this is true, now notice P is not 12. Log of P is 12. Whenever you see that, I strongly suggest you totally ignore the if part and work on the then. So then determine the exact value of this expression. Let's work on that first. So, although this one is easy. Oh my goodness. Okay, super simple. Sorry. Look at this. You already have your log base 5 of P right there. That's the same as a 12. Done. That was easy. Okay, this one is harder. This one, you have an argument here of 2 things being multiplied together. So 1 log of some stuff multiplied becomes 2 logs added, correct? So we have, oh, what's log base 5 of 5? That's just a 1. And log base 5 of P, I know that one, it's a 12. And all of a sudden your answer is 13. All right, same thing on part C. I'm going to write it as an addition statement. I know what log base 5 of 25 is. It's 2. And over here, the 3 can come down in front. Okay, I'm going to copy this 2 and this 3, but log base 5 of P, there it is again. So 36 plus 2 is 38. Nice. All right, this example, here's another one where it says, if this is true, then use the laws of logs to show this is equivalent. So always start with this mess, okay? And then we'll break it up. We'll do all the laws of logs to it, and we'll see if we can get it to work. We can use this to help us. All right. Here we go. Log base 2 of 32 plus log base 2 of x squared. This is two things multiplied together. They become two things added. What is log base 2 of 32? That's a 5. Again, that's the exponent that you need to give to the base 2 in order to get the 32. So the logarithm is an exponent that you need to give to the base to get the argument. Over here, I'm going to bring this 2 down in front. And all I need to do now, use this little thing over here. This is 5 plus 2 times a. Done. All right. Happy homework. Hope it goes well for you.